This video is on the acids and basics topic, which is 3.4.3 on the spec, and as always I'm going to start with the basics. So the definition of a Bronsted-Lowry acid is these are proton donors, and a Bronsted-Lowry base is a proton acceptor. All acid-base equilibrium reactions must have the transferring of protons. So in a few exams it said what's an essential feature of an acid-base reaction. You're going to say the transferring of protons. So we also need to know what conjugate acids are, and these are whatever donates a proton in the reverse reaction. Similarly, a conjugate base is whatever accepts and gains the proton in the reverse reaction. So to kind of demonstrate this, I've drawn this diagram below. So HA is the acid, B is the base. Obviously the HA is going to donate that H, which is going to be accepted by the B. So the acid, Bronsted-Lowry acid is HA, the Bronsted-Lowry base is the B, and obviously that forms the BH plus A minus. Now in the reverse reaction, it's the BH plus which is going to donate the proton, the H plus, and it's the A minus which is going to accept this. So as you can see, in the first reaction, HA was the acid, whereas in the reverse reaction, A is the conjugate base. Similarly, in the forward reaction, B was the base, whereas in the reverse reaction, BH plus is the conjugate acid. So it kind of flips in the reverse reaction, and this will make sense when you think about that logically. So when acids or bases are put into solution, they dissociate into their ions. So strong acids or strong bases will almost completely dissociate into their ions in solution, and weak acids or weak bases will only partially dissociate into their ions in solution. And I've drawn the acid dissociations for these two. So for the acid dissociation, we have the acid HA plus water, which dissociate in an equilibrium reaction to form H3O plus A minus. However, if you take water from both sides, so like basically simplify the equation, you'll get HA dissociates into H plus A minus. And normally both of these examples will be accepted in an exam if they ask you to just demonstrate the dissociation of an acid. The base dissociation, where B is the base, is B plus H2O to form BH plus OH minus. And just remember, whenever you're talking about a basic solution, it's always OH minus. So that's kind of how you can remember the base dissociation equation. And that's all you really need to know for the basics of the acid and bases. The next videos will get a little bit harder, but with enough practice, they're not too hard.